In this video, we're going to create a very standard whole brain treatment plan. So to start, first we need to insert our new plan. We'll select the brain as our target. For whole brains, typically 6x is used in order to provide the proper amount of superficial dose. So we'll go with a true beam and we will select 6x. We'll leave our isocenter in the center of the brain. To select our gantry angles, we're going to navigate to the slice where the lenses are located. What we want to do is rotate the gantry so that there is no divergence from either side into the opposite lens. The first step will be to look at our 3D beams I viewed and then rotate the gantry such that the 3D view of the lenses are right on top of each other. As you can see in this picture, we rotated those gantries until those lenses were on top of each other. Next, we will open the jaws to provide about 2 cm of flash around the skull. The next step will be to add our MLCs and draw our block. Typically, we leave the block open except for on the anterior side. We'll leave about 1 cm of space between our block edge and the skull, as shown. Then we can turn our brain contour on and make sure we adjust our MLCs so that we are covering the entire brain, but for sure blocking the lenses. Now that we have our first beam done, we can oppose to create our second one. When we oppose the beam, we need to rotate it so that both beams match perfectly behind the lenses. We want that line of MLCs, this orange line, to match perfectly behind the lenses. We should have no divergence in that area. We'll add our prescription and calculate dose. Now that we can see our dose, now would be the time to manipulate the field weighting if necessary. This distribution looks fairly symmetrical, so we're going to go ahead and leave our weighting at 50-50. My goal in this case, like most of my 3D cases, is going to be to block out all the 107, get our max dose less than 107. You can see we're able to normalize to get much better coverage than 95% and still have a reasonable amount of 107%. What we're going to do is we're going to create a field in field and then select the MLCs that we want to move. And then we're going to trace right next to that 107. In order to help prevent our MLCs, sometimes if you move an MLC too far, you have to create a new carriage group and they won't merge in the end. That's why I didn't go past midline there. I can just grab the other side of that 107 volume with the other side of the other MLC bank, like I'm doing now. I have After I calculate the dose, I'll copy the same procedure on the opposite side. Continue to reduce that volume of 107 and keep alternating back and forth from the right side to the left side. We've nearly got rid of all that 107, so if I don't think it's worth adding a whole nother control point or field and field to block the rest of that 107, sometimes I can just manipulate the weight a little bit. In this case it was pretty close, but let's just go ahead and add another one. Very, very close, just over 107. So let's just manipulate that control point weighting there. 107.1, I think we'll take that. It's very important to carefully review the axial dose distribution. Make sure we didn't create any cold spots. Make sure it looks all right. Then you always want to review your DVH. Look at your lens dose, look at your eye dose, brain dose, any other structures you've drawn. The last step would be to merge your field and fields, calculate dose, and then you're done.